All right, folks, we are going to begin Algebra 2 by reviewing some of the things that you learned in Algebra 1 that we are going to need. So you'll notice that we're going to start today with a review of the order of operations. Now, I know you've done this for many, many years, but I just want to make sure that we get off to a good start and that we're all on the same page. Before I start into the material in this video, I am going to be very detailed in this video. Since you are not in front of me where you can ask me questions and where I can see your faces and see if you're understanding or not. So if I am going into too much detail for you, just kind of bear with me this first week till I kind of get to know your work a little bit and see where you are. So with that said, let's go ahead and get started. All right, order of operations review. Today, you will evaluate a numerical expression using the order of operations. You'll notice I highlighted a couple of words here, evaluate and expression. Those two words kind of set the tone for what we're about to do here. So I thought we might take a second to just review the necessary vocabulary. The first word that I had highlighted there was evaluate. That tells us what we're going to be doing. When you hear evaluate, you can hear the word value in there. So when we evaluate, what we are doing is we are finding the value of the expression. So when it says to evaluate, that means to find the value of. Now, to give you just a really simple example here, here is a numerical expression, 2 plus 3. Really simple. And we all know that if we add 2 plus 3, we get 5. So that is evaluating. When I work out 2 plus 3 and I say, well, the value of that is 5, that's what we mean by evaluate. Work it out, get it down to one number, and tell me how much that expression is worth. All right, now, an expression. An expression is a type of math problem and we're going to look at many different kinds of math problems, but it's a type of math problem with no equal sign. So anytime you see a math problem and there is no equal sign in it, that is an expression. So we evaluate, find the value of expressions. We figure out what they're equal to. Now, the types of expressions we're going to be working with today are numerical expressions. When you hear numerical, that should make you think number. So a numerical expression is an expression that contains numbers and then operations. And the purpose of the operations is to tell us what to do with those numbers in that expression. So we're going to evaluate, find the value of expressions, which are math problems with no equal sign. And all of the problems we're going to do today are going to be numerical. All right. Now, order of operations. Why does order matter? You all know this, but I want to give you a quick reminder. So you'll notice here I've got two math problems that are the same. 2 plus 3 times 4, 2 plus 3 times 4. So I'm giving you the same problem twice because I want to illustrate to you why order matters, okay? So let's take that first problem. I have addition to do and I have multiplication to do. Let's suppose I decide that I want to do 2 plus 3 first. So I want to do the addition first. If I add 2 plus 3, that becomes 5. So now my problem is 5 times 4. And then when I multiply 5 times 4, the value is 20. So if I evaluate by adding first and then multiplying, I get an answer of 20. Now, same problem. This time, let's suppose I decide, well, I would rather multiply first. So I want to do 3 times 4 first. If I choose to do that, then this is going to become 2 plus 12. 2 plus 12 if I do that multiplication first. And then when I add 2 plus 12, the value of my expression turns out to be 14. So why does order matter? Order matters because if it's left up to us to choose what order we want to do things in, then we could potentially end up with different answers to questions. Now, this question is fairly simple, so there are only two possible answers. But you know, if a problem is more complicated, there could certainly be more possible answers. So order matters because we get different answers when we do the operations in a different order. So that's the purpose. That's the purpose of the order of operations, is to make sure we all come up with the same answer. So probably when you hear order of operations, the first thing that comes to mind is PEMDAS. That was the little device that you used to help you remember the order of operations. P meant do the stuff that was inside parentheses first. The E meant do exponent second. The M and the D, multiply and divide next, and then finish off by doing addition and subtraction. Now, PEMDAS is great. It's served you well for many, many years. But what we're going to do is make a slight change here. Okay? And I'll talk to you about why. We are going to change this P at the beginning of PEMDAS to a G. So we're going to do GEMDAS instead of PEMDAS. Something else we're going to change is you all are accustomed to writing PEMDAS in this way across your page. You'll notice over here that I have this little pyramid shape that we're going to use instead, because I think it does a good job of kind of setting up the priority for the operations. So we're going to start out at the very top of the pyramid, at the very tip top. And in that box, I'm going to put that letter G. Now, let me talk to you about why I made that change to a letter G. P has for years meant to you parentheses. We're changing to a G because I want you to know and understand that all types of grouping symbols get the top priority when it comes to the order of operations, and parentheses are certainly not the only type of grouping symbols. So let me show you some of these grouping symbols that we might see. You've certainly got your parentheses. Okay. Could have these square type grouping symbols. These are called brackets. Next up, we have the fanciest ones, probably the hardest to write for most people as well. These are braces. If you ever need to write braces and you have a hard time with those, feel free to do parentheses for those and then put a little line in the middle of it. That'll work just fine. Other types of grouping symbols. You may remember seeing these. Two vertical bars. You will remember that those stand for absolute value. You may remember seeing this symbol in your Algebra 1 class and in geometry as well. You know, that is a square root. That can be used as a grouping symbol. And then the final one, and I need to put some other things in here so you can see this, A over B, that fraction bar that separates that A from the B is also a type of grouping symbol. Okay, so we are going to change our P to a G so that we can understand that the top priority in any numerical expression is to do any type of grouping symbol that we see there. Okay, now let's fill in these other letters. The next level on our pyramid is going to be the exponents. So they have the second most important priority in our problem. Next, we have our multiplication and division. Now, you'll notice those are beside each other in the pyramid. What that means is that one isn't more important than the other. They're on the same level. So here's how we're going to handle that. Since one isn't more important than the other, we're going to work from left to right. It's going to be first come, first served. So if the multiplication is the first thing in the problem, you're going to do it first. If the division is the first thing in the problem, you're going to do it first. So multiplying and dividing, same priority level, same level on the pyramid. So we work left to right when we see those. And then same thing holds true for adding and subtracting. They're on the bottom of the pyramid, but on the same level. So if we see adding in the problem first, we do it first. If we see subtracting in the problem first, we'll do it first. So GEMDAS, grouping symbols, then exponents, then multiplication and division, then addition and subtraction. So far, nothing new there. You knew all of that. So let's do a few quick examples. And we're going to start out kind of easy, simpler, and then work our way up to some that get a little more complicated. So here is an order of operations question that we're going to evaluate. We're going to find the value of this expression, and it contains everything that we've just talked about. So to kind of illustrate to you what I'm doing, I'm going to come over here and I'm going to write my little pyramid, GEMDAS, so I can kind of refer to that as we go through this problem. All right, first thing we're going to do is we're going to examine the problem in front of us and see if it contains any grouping symbols. And I notice that it does. Inside of those grouping symbols, there's only one thing to do. 10 minus 6, only one thing to do. So I'm going to do that first. So that 10 minus 6 that I see inside of those grouping symbols, I'm going to do first. Now, I'm making a big deal about the fact that there's only one thing to do in there because we're going to look at a problem in a minute where that's not the case. All right, so here we go. I'm going to start at the beginning of my problem. And I'm just going to bring stuff down. 4 divided by 2 plus 5 times. And now I've reached what I wanted to do. 10 minus 6, I know is 4. So I'm going to put that inside my parentheses and then bring down my plus 3 to the third power. So now look at my problem. Here's what I have now. Before I move on to the next step, I'm going to check this line and see if there are any grouping symbols in it. And I still have my parentheses hanging around, but those parentheses are no longer grouping symbols. And the reason they aren't grouping symbols anymore is because there's nothing inside of them that I need to do. It's one number. They're just holding that 4 for me. So they are no longer considered grouping symbols because there is nothing inside of them that I need to do. All right, so I'm going to check that off. All right, now move down to the next level of the pyramid. I'm supposed to be looking for exponents. So as I look across this problem, I do see an exponent. So the next thing I'm going to tackle is that 3 to the third power. All right, so starting from the beginning, I've got 4 divided by 2 plus 5 times 4 plus 3 to the third power. Now you all will remember that 3 to the third power means we want to do 3 times 3 times 3. So the first two, 3 times 3 makes 9, and then 9 times 3 makes 27. So I'm going to replace 3 to the third power with 27. Now, you guys certainly can use a calculator to help with any of this stuff that you need to. I don't have a problem with that at all. I do want to say, though, that I want to see these steps in your work. I think it's important, especially for right now, as I'm getting to know you and your work, to make sure that you understand everything. And then as we go further and get past this, I will let you start to kind of shortcut some of this a little bit. All right, so now I'm going to look at this one more time to see if there are any more exponents, and I don't see any more, so exponents are done, and I will move along. So next, I'm at the multiplying and dividing phase. Multiplying and dividing. And when I look at my problem, I have a division, 4 divided by 2, and I have a multiplication, 5 times 4. Now, like I said before, multiplying and dividing are same priority. One isn't more important than the other. So the question for me is, which comes first? Is the division first in the problem, or is the multiplication? In this case, I can see that the division is first. So the next thing that I'm going to do is 4 divided by 2. All right, so 4 divided by 2 is 2, plus 5 times 4, plus 27. Now, looking again in this line, any more multiplying and dividing, because I don't want to go on until I have it all done. And I see right here in the middle, I've got this multiplication that needs to be done. So I'm going to handle that next. So 2 plus 5 times 4 makes 20 plus 27. And once that's done, I can see no more multiplying or dividing. So finished with that. Now we're down to that last step. We're going to add and subtract. There are only additions to do. So we're working left to right. We're going to do 2 plus 20, 22, plus 27, and then 22 plus 27 gives us 49. So the value of that expression that we started with is 49. Now, as you do your work today, as you do your practice today, this is what I want to see on your notebook paper. I want to see step by step. I want to see one operation done per step. So be detailed today. Be detailed on this first assignment. And then after we get through the first assignment, then we'll start kind of shortcutting. All right, so there's that. Now, here is, actually, I think we can skip this one. So that one's kind of like that last one. Here's where I want to go next. All right, so we're going to evaluate this expression. You'll notice this time we've got brackets in this problem and parentheses. So we're going to talk about that just a bit here. So to evaluate, we're going to go through this GEMDOS process. All right, so to get me started, I am on the lookout for grouping symbols. Okay, the first grouping symbols that hit my eye are these brackets. Okay, now here's what makes this problem different from this problem that we just completed. When I look at this problem and I look at my grouping symbols, there was only one thing to do inside, and that was 10 minus 6. But when I look at this problem and I look at my grouping symbols, okay, there's more than one thing to do in here. This is a multi-step problem in here. It has grouping symbols, it has division, it has an exponent, so there's a lot of stuff going on in here. So here's what I need you to understand, okay? When you look at your grouping symbols, and I'm going to cover up this minus 14 so we're not distracted by him for a minute, okay? When you look at your problem inside the grouping symbols and you see a multi-step problem like this, then what you're going to have to do is take this multi-step problem right here, this one, and you're going to have to follow the order of operations to do it. I'm going to have to work on this multi-step problem until I get it down to one number. All right? So what I'll do is I'll look at what's inside those brackets and I'll look and see if it has grouping symbols. And it does. It has parentheses. So the first thing I'm going to do in this problem is the 14 plus 2. So I'm ignoring that minus 14 and I'm working this out like it's a GEMDOS problem because it is. All right, so here's what will happen. You've got your bracket. 14 plus 2 is 16. And then you've got divided by 2 to the third power. And then there's that other bracket, and then you've got your minus 14. Now, on this part of the problem right here, you've done the grouping symbols, so you can check that off. But for the entire problem, you are not done with the grouping symbols because there's still stuff to do inside of those brackets. So I hope that makes sense. If it doesn't, then certainly feel free to email me and let me know. Let me know what your questions are, okay? So I'm still over here working on just this. Now I'm going to look at 16 divided by 2 to the third, at what I have inside of there, and I'm going to see if that has any exponents. And it does. It has 2 to the third power. So I'm going to do that next. So I have my bracket, and I have 16 divided by 2 to the third power, you know, means 2 times 2 times 2. So that's going to be 8 when all is said and done. And then we have minus 14. Now again here, I'm still just working on those brackets. I'm still just working on that multi-step problem that was inside of those grouping symbols. So I'm done with the exponents in this expression, but still not done with these grouping symbols that I had to begin with. Okay, so now I'm looking at my problem inside of those grouping symbols, and I'm seeing if it has any multiplication or division. And it does. It has 16 divided by 8, so I'm going to do that next. 16 divided by 8 is 2. Now I want you to notice something. Here is the point where we have finished these grouping symbols, because now it's down to one number. I've done 14 plus 2 divided by 2 cubed, and it's finally down to one number. So this is the point where I can say, hey, these grouping symbols now are done. And I can drop those brackets out of my problem. I don't need them anymore. And I have minus 14. So when you see a multi-step problem inside grouping symbols, you have to work on that multi-step problem using GEMDOS until you get that down to one number. And then you can leave this behind and continue on through your simplifying. Like I said, I hope that's making sense. If it's not, you'll let me know. All right, so now I check this expression to see if there are exponents involved. 2 minus 14, no exponents. So that's over. I look next to see if there is multiplication or division. 2 minus 14, no multiplication or division. And so now I'm at the end where I would add or subtract. That's the only thing left to do is that subtraction. So 2 minus 14 puts me at negative 12 for my final answer. So when I evaluate this expression, I get negative 12. So again here, just to emphasize, grouping symbols with only one thing to do. We do that one thing, we get it down to one number, and then we can proceed. Grouping symbols with a multi-step problem inside. We have to follow GEMDOS to get this multi-step problem worked out. Our minus 14, anything outside those grouping symbols is just going to kind of hang around and wait. But I got to do all these steps to get this done before I can proceed with the rest of the problem. All right, now that's just a basic reminder about how order of operation works. Now, let's talk in a little more detail about some extra things that can be added to your problems. I mentioned already that absolute value and square roots are types of grouping symbols that we might see in these problems. So you should always plan on treating those as grouping symbols. A square root can also be treated like an exponent. And I'll talk more about that as we go through this, but I need to remind you about a couple of things here. First of all, absolute value, you will recall, is these pretty vertical bars. And I need for you to remember that absolute value means distance from zero. So if you're picturing a number line, the absolute value of a number is how many spaces that number is away from zero. So if I were to do the absolute value of a negative 5, I'm saying to you, how far is negative 5 away from zero on a number line? Well, you know that's 5 spaces. So the absolute value of negative 5 would be a positive 5. Okay? If I were to do the absolute value of a positive 5, now again, that's saying how far is positive 5 away from 0 on a number line? Well, you know that's 5 spaces as well. So that's going to be 5 as well. So you may remember absolute value takes negative numbers and turns them into positives. And it takes positive numbers and leaves them positive. And the reason it does that is because it's a distance. We're talking about how far something is from 0. And distances just aren't negative. Now, a square root, which is that symbol, you all will remember is the opposite of squaring a number. It's the opposite of squaring a number. So if I were to ask you for the square root of 9, then I'm saying what number would you square to get 9 as the result? So I'm saying what number would you square to get 9 as the result? And you know that's 3. So the square root of 9 would be 3 because we would have to do 3 to the second power to get 9 as the result. If I ask you for the square root of 49, then I'm saying what number would you square to get 49 as the result? And of course the answer is 7. So a little bit of review here. Now what we're going to do is put these two concepts into our order of operations question. So here's the next one we're going to look at. We're going to evaluate this expression, and you'll notice it has absolute value bars in it. So again, let me get set up over here. You probably won't need to do that, but I just feel better since, like I said, you can't ask me questions, kind of showing you in detail what I'm doing and what I'm thinking. All right, so I'm going to look at this problem that I see in front of me, and I am going to look for grouping symbols first. Okay, my problem has grouping symbols, which are these absolute value bars, and when I look inside of them, there is more than one thing to do. I've got subtracting and I've got multiplying. So inside of here, I've got this multi-step problem. So I'm going to have to work that problem out, 5 minus 2 times 9, and get it down to one number before I can go any further. All right, so in here, we're going to go a little quicker. There are no grouping symbols in 5 minus 2 times 9. The parentheses are not grouping because there's nothing to do inside of them. 5 minus 2 times 9 also doesn't have any exponents. 5 minus 2 times 9 does have multiplying, so I'm going to do 2 times 9 next. So that's going to be the absolute value of 5 minus 18 plus 9 squared divided by 3. Now, 5 minus 18 doesn't have any more multiplying or dividing, so now I'm going to do the adding or subtracting. 5 minus 18 is a negative 13. So that's done. I've got that down to one number. So I was inside my grouping symbols. I saw a multi-step problem. So I went through the order of operations for 5 minus 2 times 9, and I now have that down to a single number. All right, now, before we move on to exponents, let's talk about something here. Absolute value of negative 13, now that you have that down to one number, you can actually figure that out. What is the absolute value of a negative 13? Well, what that means is how far is negative 13 away from 0 on a number line? 13 spaces. So I'm going to go ahead and change the absolute value of negative 13 to positive 13 plus 9 squared divided by 3. So once you get that absolute value down to a single number, then you can take that absolute value and get those out of your problem. Makes it simple. Okay, so I dealt with my grouping symbols. I worked out that multi-step problem, and now I'm going to continue on. So now I would look at my problem to see if there's an exponent in it. 13 plus 9 squared divided by 3. I've got the exponent 9 squared, so that needs to be the next thing that I tackle. So that's going to be 13 plus 9 squared. 9 times 9 is 81 divided by 3. All right. Now, when I look at 13 plus 81 divided by 3, there are no more exponents. So I can check that off, and now I'll move on to multiplying or dividing. All right, 13 plus 81 divided by 3, I see a division. So we're going to do that next. 81 divided by 3. So that's going to make this 13 plus 27 13 plus 27, I don't see any more multiplying or dividing in that. So now I finish this off by doing the only thing that's left to do, which is an addition. 13 plus 27 is going to be 40. So 40 is the value of that expression. So treat those absolute value bars just like they are grouping symbols. All right, now, I know how much you all love fractions, so I wanted to remind you about a fraction bar as a grouping symbol. So when I look at this, there is my fraction bar. That is a type of grouping symbol because it creates two groups. Here is the top, and then the bottom. So what we're going to do when we see a problem like this is we're going to have to work on these two groups separately in the beginning. All right, so I'm going to put my top problem over here. And you know, certainly as I'm writing this down, you could leave this fraction altogether and work on it all at one time. I'm going to choose to split it up just so I'm sure that I'm showing you where everything comes from. So you do what is most comfortable for you. All right, so on the top, does it have any grouping symbols? And the answer is yes, it has these parentheses. And inside the parentheses, I see an exponent, 5 squared, and I see a subtraction. I'm subtracting 1. Okay, so I got to work 5 squared minus 1 out and get that down to one number. There's an exponent, so I would do that first. So that's going to be 18 minus 25 minus 1 plus 27. Still got to work on these grouping symbols because it's not down to one number yet. So 25 minus 1. So that's going to be 18 minus 24 plus 27. So now my grouping symbols are finished. This doesn't have any exponents. It doesn't have any multiplying or dividing. It does have addition and subtraction. And remember, in that GEMDAS, adding and subtracting are on the same priority level. So the question is, which one is first in the problem? And it's the subtraction. So we're going to do 18 minus 24, which is a negative 6 plus 27. And then we add negative 6 plus 27 and we get 21. Now that's not the answer to the problem. That's just the answer for the top. So I'm going to go ahead up here and put 21 on the top of my fraction. Now we work out the bottom. No grouping symbols, no exponents, only one multiplication, 4 times 2. So that's going to be negative 1 plus 8. And then only an addition, negative 1 plus 8 is 7. So the bottom is 7. So now remember that fraction bar means divide. So to finish this off, we'll do 21 divided by 7. And the final value of that expression is 3. So when you see fractions, the top and the bottom have to be worked out individually, as if they were two separate problems. They're two separate groups. And then we can put them back together and finish at the end. All right, one last one. Notice again your fraction bar. So that creates two groups. Whoops. All right, here we go. All right, on the top, does it have grouping symbols? And the answer is yes. We have these absolute value bars. And notice inside, it's multi-step. So I have -2 minus 7 times 3. I'm going to do that multiplication first. So this is 5 times the absolute value of -2 minus 21. All right, still working on my grouping symbols. I need one number in here. So I'm going to subtract now -2 minus 21. So that makes this 5 times the absolute value of -23 minus 2 times 17. Now, grouping symbols are done because that's down to one number. But now I need to take the absolute value of -23. So how far is it from 0? And the answer is 23 spaces. So 5 times 23 minus 2 times 17. So grouping symbols taken care of. I worked all of that out, got it down to one number. All right, does it have exponents? This problem has no exponents in it. So I'm moving on. Multiply and divide. No division, but we do have 2 multiplications. So we'll go ahead and do both of those. 5 times 23, we get 115. Minus 2 times 17, we get 34. And now notice the only thing left to do is 115 minus 34, which gives us 81. Now 81 again is just the answer for the top. On the bottom, do we have grouping symbols? And the answer is yes. This square root is acting as a grouping symbol because we need to do 7 times 28. We need to do what's inside of it. So that would be our first move, 7 times 28. That is 196. So this is going to become 22 plus the square root of 196. Now at that point, you're done with your grouping symbols because you have 7 times 28 down to one number. Now here's what I was saying earlier about a square root. A square root acts in a problem sometimes as a grouping symbol, sometimes as an exponent. And in this case, it's acting as both. It was a grouping symbol because it had 7 times 28, and now it's acting as an exponent because the next thing I would need to know is what is the square root of 196. You can use a calculator to find out that that is 14. So this becomes 22 plus 14. There is no multiplying or dividing in this problem. I have adding to do, so I'm going to do that. 22 plus 14 is 36. All right, so that is a quick rundown and review on order of operations. I think we've covered all of our bases. If there was anything that you did not understand or that you have questions about, then contact me through email, through Schoology, or even call the school if you need to. But the important thing is, let me know if there's anything that's not clear so we can set up a time to meet online and get those questions taken care of. Your assignment is posted in Schoology. Show your work. Do that on notebook paper and turn it in as you get it done. All right, y'all have a good day and let me know if there's anything that I need to do for you.